We're going to look at solving inequalities today. Now, you guys are used to dealing with inequalities written like this and doing number lines with open circles where there's no equal to and closed circles where there is an equal to. We're going to take a look at a slightly different version of that called an interval notation. Now, whenever you have something like this, you're looking at what is in between 5 and 8. Oh, just a second here. Yeah, I didn't have my numbers lined up, so I had to move them all over just a touch. So we're looking at what's in between 5 and 8. We have x in between 5 and 8, so we're going to shade in between 5 and 8. Now, whenever there is an equal to here, that's a square bracket. Whenever you have just a greater than or just a less than, that's a curved parenthesis. So we've got to have the curved parenthesis at the 8. We need to have the square bracket at the 5. That's what we have over here. And then you can write your interval notation. Now with interval notation, we have a square, 5, comma, 8, and it's ending with a curve. Now interval notation is always smallest to largest. So it's always easy to get from your number line because your number line always goes from smallest to largest. So if we're looking at this next one, you're just looking in between 2 and 7, but you're no equal to, so you're not square. They're both curved, so it's curve 2, comma 7, curve. Next one down, they're both equal to, so they're both square brackets, and the square and the parentheses always go towards where the shading happens to be. We also have a bottom one where it goes smaller than 2 forever. So that would be like this. So what do you do when there's nothing over here? Well, it's coming from negative infinity. So over here is negative infinity. We're coming up and we're ending at 2. There's a square at 2. Infinities, well, let me side note. When you're dealing with a square bracket, that's an equal to. That means you're including that number. So yes, we're less than or equal to 2. We're not including infinity though, because infinity is not a number, infinity is a concept, so that needs to be in parenthesis. Infinities are always parentheses. So we'll go ahead and we'll work this out. We're solving inequalities. Solving inequalities is very similar to solving equations with one minor exception, and we'll get to that in a bit. So we want to try to get the x's on one side, get the non-x's on the other side. So we could add 8 to both sides of an inequality. Then we could go ahead and take our x's to the left-hand side by subtracting a 5x on both sides. Now we'd end up having to divide both sides by -4. That's where we have to do something different than it is for an equation. Consider this. You know that -2 is smaller than 5. If you multiply both sides by a +3, you get -6, which we know is still less than 15. But if you take that same inequality and you multiply both sides by -3, well, then a negative times a negative is positive. A positive times a negative is a negative. Then we get 6, and we know 6 is greater than -15. So if you multiply or divide both sides of an inequality by a negative, you got to switch your inequality sign. So we got to divide by -4, so we switch our inequality sign. And so then we get x to be less than 11, -11 over 4. So I'm going to come along and I'm going to put -11 over 4 in my number line. And because I want less, that's going this way. There's no equal to, so that means I'm curved right here. So I'm coming from negative infinity, which is always curved, coming up to -11 over 4, which has a curve by it. Then we'll solve our top next one. We're going to try to get x by itself, so you got to get rid of that +3. So subtract 3 from all 3 parts. and we would get this. Then you got to get rid of that timesing by 1/4. So you can divide by 1/4 or multiply by its reciprocal of 4. Multiply everything by 4. Notice I'm not changing my inequality signs because I'm multiplying everything by a positive 4. So I get negative 20 here. I just get x here. And then I just get an 8 there. So I'm going to put 20 negative and 8 on my number line. And I have x in between, so that means I'm going to be shading in between. Also, you'll notice there's an equal to in the 8. Equal to's are always square. There's no equal to on the 20 here, so that's a curved. And so if there's no equal to, it's a curved. And so it's always smallest to largest, left to right. As you see it down here, curved, negative 20, 8, square. So we'll go ahead and solve this one here. You'd want to get rid of the parentheses, distribute through, FOIL out the right-hand side. Then you can get everything on one side, set equal to, or so zeros on one side. Or you'll notice in this case, you have a 12x squared on each side, so subtract the 12x squared from both sides. You get then just your 10x, your negative 5x, your negative 2. And so then that's just a nice normal inequality. So you want to try to get the variables on one side. So I'm going to add a 5x to both sides. Then I'm going to go ahead and divide by 15. I'm dividing by positive 15, so I do not switch my inequality sign. I only switch my inequality sign if I'm multiplying or dividing by a negative. So I'm going to go ahead and put negative 2/15 down. And I want less than, so that's going to be over here. There's no equal to, so that's curved. So I'm coming from negative infinity, which is always curved, coming up to negative 2/15, which is curved. Couple of little side notes over here. If you had absolute value, and it wouldn't make a difference what was in your absolute value of anything, if it's less than 0, you know absolute value is always positive. Would a positive here on the left ever be less than a negative over here? Well, we have a positive less than a negative. That's not going to work. Now, on the other hand, if you had your absolute value with a greater than a negative, that's always going to work, because the left side over here is positive. And we know a positive is always larger than a negative. So consider this fraction. It's less than 0. So that means it's negative. Well, if we have a negative fraction, the top's already positive. What would the bottom have to be for us to get a negative answer? Because we're looking for something less than 0, which is negative. Well, if the top's positive, the bottom would have to be negative. So we could just say the bottom has to be negative. Negative means less than 0. I'm not going to say less than or equal to, because I don't want 0 to be in the bottom, and I'm looking at the bottom here. So then I'd just go ahead and I'd solve this. So I'd subtract 5 from both sides, divide both sides by 2, and I end up getting a negative 5 over 2. I'm going to the left, so that's over here. There's no equal to, so that's curved. And so I just get this. So you guys know that absolute value means distance from 0 on the origin. So when we're looking at absolute value of x less than 4, I'm looking for my distance being less than 4 away. So it could be at 0, close to positive 4 on the right, or almost all the way back to negative 4 on the left. So in other words, I'd be looking for anything that's less than 4 units away, which would be between 4 and negative 4. That's one inequality, so I could write that as one compound inequality between 4 and negative 4. Notice it goes left to right just like your number line does, and it's always less than signs. Now technically you could write this as two separate inequalities joined with an and statement, but I prefer just writing it as one compound inequality. Now on the next one down, what does absolute value of 4 or greater than 4 mean? That would mean all the numbers more than 4 units away from 0. So that would be starting at 4 and to the right of 4, or to the left of -4. So if I'm looking at this, that's everything to the right of 4. That's x is greater than 4. If I'm looking at this, that's everything to the left of -4, or x is less than -4. Now, you could look at, just a second, this second one here in blue is not right, so ignore that for now. So for the most part, if it's absolute value followed by a less than, you can write it as one compound inequality. And so that's what we're saying down here in yellow. If it's absolute value followed by a greater than, it's two totally separate shaded regions on your number line, so you have to write it as two totally separate inequalities. So now we're going to solve each one of these. Here we have absolute value followed by greater than. That's what we were just dealing with over here, highlighted in green. So you're going to write it as two separate inequalities. If what's inside is positive, absolute value is doing nothing. It's absolute value followed by greater than, so you got to do an or. Then you got to consider the situation if what's inside is negative, absolute value makes it positive by doing the opposite of that, because the opposite of a negative is positive, and that's what absolute value gives you, greater than 5. We solve each one of these inequalities. And we get this. So then we need to have x greater than or equal to 4. Well, if we graph that, that's going to be at 4 and going to the right. Because of the equal to, that's going to be a square bracket. X is less than or equal to 2/3. You got to be at 2/3 and going to the left. So I have x being less than 2/3, so I'm going to go to the left of 2/3. So I have two totally separate regions on my number line, so I have to write it as two totally separate inequalities and two totally separate interval notation. So I'm coming from -infinity, coming up to 2/3, that's got a square. Now, if there's an or, you use that for inequalities. We're doing interval notation, so we put a u in here. There's no tail on the U, it's just the U shape. And then we start at 4, go up towards positive infinity. The next one is absolute value followed by less than. Absolute value followed by less than is written as one compound inequality. So what we would have here, and then go less than, and then instead of putting 1, we do the opposite of 1 over here. And then we'd have to solve this. So we'd have to get rid of the dividing by 3, multiply everything by 3. And we get this. By the way, this purple, or not purple, blue 3 cancels out the divide by 3 here, leaving us just with what was on the top. Now we'll go ahead and get rid of the 5, so subtract 5 from everything. Then we'll divide by the 2. And then we can go ahead and graph that on a number line. We're looking at everything in between -4 and 1. -4, -1, everything in between. There's no equal to, so then we know we have curves. And then we could write our interval notation.